Right, hopefully that's working. Sorry? Yep, very quickly. Okay, so just reminding myself to record. So we're starting on equation today. So fair bit of it you've seen before. We're going to look at different type of equations. Going to move on to going through solving simultaneous equations. Okay, so what you used to, also looking at solving simultaneous equations, we've got powers involved as well, so quadratics, as well as linear functions. So a little bit to do in this topic. Right, so 3.1, simple equation. So if I ever taught you equations before, I've been referring to them as 1-step, 2-step, 3-step. Okay, so when we go to simple equations, that's what we're going to be looking at, those 3-step style equations. Alright, examples. Alright, keep in mind when we solve equations, we've got to perform the opposite or the inverse operation in each step. Okay, so let's start at some simple 1-step equation. Alright, so what the aim of the equation is to get the variable by itself, in this case x, and I need to do the opposite to adding 6 to both sides to solve for x. Okay, so I do the opposite, which is take away 6. So what that achieves, 6 take away 6 equals 0, x plus 0 is x, and then I'll do what's on the other side of the equal sign as well. 10 take away 6, 4. Okay, B. Y take away 8 is 20. So the process of solving equation is to do all the necessary steps in reverse to get the variable by itself on one side, and you should have the solution on the other side. Right, so y take away 8 equals 20. So in other words, what number, when you take 8 away from it, equals 20. Okay, so that will be 28. Take away 8 will give me 20. And to do that, with my equation skills, I do the opposites, taking away 8 on both sides. So y, we add 8 to both sides. To eliminate the negative 8, we take it over to the other side. Is the other way to look at it. Right, C. Right, so you should know that there is a multiplication sign in between numbers and letters. Right, so that's a 5 times m equals negative 45. So we either think what number multiplied by 5 gives me negative 45, or what's the opposite to timesing or multiplying by 5, so that I can solve for the variable. Right, so if I divide both sides by 5, that will cancel the fraction, the numbers on the fraction on top and the bottom. And then I've got negative divided by a positive, so we're going back to our directed numbers. The result will be negative, opposite sign dividing negative. Okay, 45 divided by 5 is the same as 5 times what? Equals 45, so equals 9. D. A on 3 equals 7. So a fraction is division, okay, so the numerator divided by the denominator, how we read that. And to do the opposite to dividing by 3, I'll multiply by 3 on both sides. Right, so what this solution means, if I substitute that variable, the number representing the variable back into the original equation, I'm going to get the same number on both left-hand side and right-hand side. Okay, so in other words, if I put it back into the original equation, we've got 21, so replace that p with 21. over 3 equals what's on the right hand side, which is 7. So 21 over 3, same as 21 divided by 3, which is 7. And 7 is 7. Okay, 7 equals 7. So that's your way of checking solution to your equation. Okay, and particularly as we step it up. So they are the fundamental steps. Okay, so our 4 basic arithmetic, doing the opposite when you get to that final step. In this case, we are already at the final step, but in the example to come, you'll need to do more than one thing before you get one or more thing before we get up to this stage here. Right, so now we're moving to 2 steps. So you need to do 2 things to solve for the equation. Okay, so you should have a variable multiplied or divided by another number, and then you add or subtract something. That's your usual method for 2 steps equation. It will equal some other number on the right hand side. So the first thing we do is we undo any addition and subtraction first. So we're going almost, not always, almost, the reverse order of your order of operation. So I undo the -2 by adding 2 on both sides. So 8a, -2 plus 2 becomes 0, so I'm left with 8a. 46 plus 2 is 48. Now I'm down to that one step that we've done in the first 4 examples, so that I can do that final step. Let's do the opposite timing by 8, which is dividing by here. So 48 divided by 8 is 6. Okay, so when you're doing these questions, we should be doing a quick check. Okay, sorry, I recommend you do a quick check. So 8 times 6, which is 48, take away 2, so it's 46. Okay, so you're doing a quick check, making sure you've got the correct solution. F. Right, when you have grouping symbols, there's one of 2 things you can do. Okay, the first option you can do is you can expand and remove the grouping symbols like we've done in the previous topic. Okay, the other thing you can do, because 4 is multiplied by everything inside that bracket, and the last thing we do in our order of operation, so the first thing we do in our order of operation is bracket. Okay, so we do the reverse operation, do any addition, subtraction first when solving equation, then any multiplication, division, and then any brackets. Okay, so going back to the reverse order to solve the equation. So you can expand this, or what I'm going to do is I'm going to divide both sides by 4 because of the grouping symbols. So 12 divided by 4 is 3. Okay, so back down to my basic one-step equation. Do the opposite, take away 3 on both sides. So x equals 6. But the alternative, or we can expand. So 4x, take away 12. Okay, so you solve it going that way. Okay, so you add 12 to both sides, you get 4x equals 24, and divide both sides by 4, and you'll have x equals 6 as well. Okay, it doesn't matter how you do it, you get the same answer when you perform the same steps. Again, so x equals 6, so 4 outside of 6 take away 3. So do what's in the bracket first, is 6 take away 3, which is 3. 4 times 3 is 12. Okay, so quick check, making sure you've got the correct solution. Are there any questions? So, alright, so there are 2 steps, so there are 2 things you need to do to solve. So now we're looking at 3 steps. 3 or more, sorry, steps. G. 5x take away 2 equals x plus 17. Right, so in this case, usually we have the variable on both sides of the equation. So we need to do 3 or more things in order to solve. So, step number 1, move all variable terms to left-hand side. So I have 5x take away 2 equals x plus 17. So when I say left-hand side, right-hand side, I'm referring to the equal sign. Variable term on RHS, sorry, because the stuff's already on the left. So we still have the x term on this side, on the right-hand side, so we need to move that first. Alright, so this is a positive x. So undo the positive, or do the opposite operation, which is a negative. And I'm going to write it underneath the variable, okay? I'm not just going to put it here. I'm going to line everything up so I can see in structure of the columns what I need to do. So, 5x take away x, 4x, I still have the negative 2, I haven't done anything with that, so I need to write that down as well. But what I have achieved is x take away x, which is 0, and I've still got the plus 17 there. I don't need to write the plus sign, but I'm just letting you know you also need to write that sign if it's a negative. Right, so there are no variable terms on the right hand side. Then I can move on to step 2. Move all numerical terms on left hand side to the right hand side. And numerical means numbers, no letters. So, on the left-hand side, right-hand side, we're referring to the equal sign. So on the left-hand side, I've got the negative 2 as my numerical term there. So I need to do the opposite to my negative 2, take away 2, which is adding 2 to both sides. So I've still got the 4x here from that side because I haven't done anything with that. But what I have achieved, negative 2 plus 2, which is 0. So I will move that term over to the other side. So 17 plus 2, 19. So you should get to one-step equation at this stage. Okay, so solve one-step equation. Like we've done the first 4 examples, do the opposite operation, both sides, to undo and get the variable by itself. Now, in this case you can leave it as an improper fraction. Okay, that'll be fine because I hadn't specified what format of your answer is in there. Okay, so we can leave it just like that. Don't need to go through the extra working to convert that to a mixed or decimal. Okay, unless you've been told. If it's been told, you've been told so to write it as a mixed fraction, or you need to convert that to a mixed. Okay, by using your skills or put it in your calculator. Right, there's any questions on the process? Right, let's try another one. 9a plus 8 equal to 3a plus 44. Right, so if you're not feeling very comfortable with 3 steps, follow the 3 steps over that side there. Okay. Step number 1, remove the variable terms on the right hand side of the equal sign over to the left hand side. So what I need to do is move that 3a from the right hand side to the left hand side by doing the opposite. So this is a positive 3a because there's no minus sign there. And I'll also do the same to the other side while lining up what I'm doing underneath the like terms that I'm adding or subtracting. Okay, this will give you a better structure in your work. So 9 apples take away 3 apples. And then I've still got the plus 8. I haven't done anything with that yet. But what I have achieved, 3 apples take away 3 apples is 0 apples. And I still have the positive 44 to bring down. Alright, step 2, move the numerical terms on the left hand side over to the right hand side. So take away 8 from both sides there. Okay, again, lining them up underneath like terms. 6a, 44 take away 8, which is 36. And then step 3, I should have a variable term on one side and a constant numerical term on the other side. Solve my simple one-step equation. So 36 divided by 6, which is 6. Alright, if you're doing an assessment, for example, and you're finished reasonably early and you've got time to check your work, okay, so instead of checking your work in here, okay, what you can do is substitute this answer back into the original equation. So over here, let's go 9 lots of 6 plus 8 must equal 3 lots of 6 plus 44. So what I've done is replace my a's with the solution that I've got, and then I'm going to evaluate both sides of the equal sign and show that both numbers are going to be the same. Yep. Yep. Good. Okay, 9 times 6, which is 54 plus 8 is equal to 18 plus 44. So I did 9 times 6, 54, took it at the 8, 3 times 6, I'm going to need to add the 44, so 62 is 12 plus 10, which will also equal 62. Okay, so that's what you're trying to achieve. Get that variable that makes both sides of that equation true. Okay, so assuming your arithmetic is correct, we've got the correct solution down here. Do you all have go at similar 3-step equations last year? Yeah. Yeah? Two more. 7 outside of 2x, take away 3, equals 9x. Okay, so these were called 3 or more steps, so sometimes you'll need to perform that first extra step so that you can do 3 steps. Okay, in this case you need some expanding. So in the previous question I said you could divide first, but all that will achieve is you're going to have an improper fraction on the other side, and we want to try and remove all fractions quickly. Okay, we don't want to deal with fraction, we want to deal with whole numbers and variables. So the first thing I'm going to do, expand. So 14x take away 21 is equal to 9x. Alright, and then I can follow my 3 steps. So step number 1, terms on the variable terms on the right hand side, move to the left hand side by doing the opposite operation on both sides. So 5x, I haven't done anything with that negative 21 yet, and on the right hand side I'll have 0. Step 2, numerical terms on the left hand side, move over to the right. So plus 21, plus 21. Do the opposite, negative 21 on both sides. So 5x will equal 21, 0 plus 21. Okay, so you won't always get whole numbers solutions for your variables. Sometimes you will get fractions. And again, I haven't specified the format of your answer, so just leaving it like that, of course in simplest terms. So if 21 and 5 have a common factor other than 1, I should be simplifying. Always simplify a fraction to the simplest form, unless told otherwise. But I haven't been told the format of the answer, so I'm going to leave it like that and not create an extra line of working for myself. Okay, saving time. Right, last one. Right, noting as well that all my equal signs are pretty much underneath each other, all in a line. One line of working per, sorry, one equal signs per line of working, and working down the page. Okay, I don't want to see people working across the page. If you need to, you put a column in the middle of your work, okay, and then you can work down your columns on both sides. Okay, but you should be structuring it similar to what I've got on the board here. Okay, so I'm looking at the numbers out the front. So 3 divided by 4, 4 divided by 3, still going to give me the fraction. So I'm not going to divide first, I'm going to expand. Whoops. So 9y plus 3 is equal to 4y plus 32. Okay, so expand using my skills from chapter 2. Now I've set it up to a 3-step equation, I can then follow my steps. So step number 1, move the variables on the right hand side to the left hand side. So 5y plus 3 is equal to 32. Step 2, move my numerical terms on the left hand side over to the right hand side. Many examples of picks have been fraction answers, not whole numbers. That's okay, but what we're concerned about is the steps. Okay, so you can show me that you understand the steps. You should be able to get all of these correct. Okay, no common factors, can't break that down any further, hasn't specified me what form of the answer, so I'm going to leave it like that. Right, again, you can substitute that answer in place of y on both sides, solve for both sides, see what number you get. If this is correct and the arithmetic is correct, okay, you should get the same solution on both sides. Right, so that's exercise 3.1. Right, questions? Right, so you've got 10 minutes.